Okay, so I'll share my whiteboard. You would be able to see that in a bit. All right, so let's get started. This is a new chapter. We'll talk about this today, congruence and similarity. Okay, so these are two definitions, two different terms. Let's just understand the meaning of congruence and then similarity, and then we'll talk about it. Okay, so I'll write down two more definitions. So two shapes are congruent. We'll talk about triangles specifically. So exactly same triangle. Okay, we'll only talk about triangles in this chapter. This means that all angles are same and all sides are same. Okay, so I have not explained anything so far. I would explain that. Just give me 1 minute and then I'll tell you. Let's say I have two triangles. Okay, this could be a good idea. I'll make two triangles out of this. Okay, now I have two triangles. Let's say the side is A, B, C, D. Okay, so I have triangle ABC and I have triangle ADC. Okay, we are talking about congruence. Okay, let's see if these two triangles are congruent to each other or not. These two triangles, triangle ABC would be congruent to ADC if all angles are same. Okay, so since, let me just add this, we have these three angles and we have these three angles. Okay, so these are the three angles in both these triangles and they are equal. Okay, I'm telling you they are equal. When we'll talk about the angle properties over there, I would be able to prove that, but for now just trust me, these angles are equal and all sides are same. What do they mean by all sides are same? This does not mean that this side, and this side is same. No, this means that the corresponding sides are same, right? That is, this side is equal to this side, then these two sides are equal, and then obviously the black side is same, so that is equal. So in both these triangles, all the sides are same, all the internal angles are same. That is why ABC and ADC are congruent. Okay, I'll give you proper examples. For now, I'm just explaining you the concepts. Okay, so I'll rub this. We know the basic idea of this chapter and we'll talk about similarity. Okay. All right. Now here I'll make two triangles. Let's say this is a triangle and this is another triangle. And you have been told that this side is 60, this is also 60, this is also 60, this is 60, this one is also 60, and this one is also 60, right? So since all the angles are same, this means that both these triangles are similar triangles, right? Now, if both these triangles are similar triangles, we have been told that in case of similar triangles, we have proportionate sides. So this means that let's say if this side is 4, this is also 4, this is also 4, this would be 8, 8, and 8. So what is the proportion? Every side of this triangle is 2 times greater than every side of this triangle, right? So I did not tell you how to calculate any side. I did not talk about how to prove congruency, how to prove similarity. The only thing I want you to understand is that in case of two congruent triangles, their size, their shape, their angles, their lengths, everything is same, okay? They are exactly the same. And in case of similarity, they have a similar shape, but the main thing is that their angles are same, okay? And their sides are not same. Their sides are proportionate. So if this side is 4, this one is 8. If this, let's say if this side is 6, this would have been 12, right? For example. So what is the proportion? The fact that every side is 2 times greater than every side of this triangle, that has told me that if this is 6, this would be 12, right? So any confusion so far, Saneem, Mahnoor, and Turhan, please tell me. I did not talk about how to calculate any sides. I did not get into details. So far, I just want you to understand the difference in congruency and similarity.
It's clear.
Okay. All right. So first, I'll start the discussion with similar triangles. Then we'll come to congruence. Okay. All right. So I will rub this. Turhan and Manur, please tell me if you have understood this. Okay. I have a message. Yes, Turhan. Okay. All right. Very good. Now we'll talk about some examples and things would get clear. Okay. Please feel free to stop me if you have not understood anything. You guys know already that I'm not the type of teacher who, minds questions and all that. Okay. All right. So first question is prove that the triangle ABC, which I will make shortly, is similar to triangle PQR. Okay, so I'll make two triangles. So okay, so these are the two triangles. I'll label them quickly. This is A, B, C, and this is P, Q, R. And you have been told that this side is 9, this is 10, this is 11, this is 4.5, this is 5, and this is 5.5. Okay. Now, what is the thing? You need to prove that these two triangles are similar. Okay. So we know a few things about similar triangles. We know that their angles should be exactly same, right? That means that this angle at B and angle at Q, they should be same. Angle at A and angle at P, they should be same, and angle at C and angle at R, they should be same. But I do not have any information about the angles, okay? So that's useless. In order to prove that both of these triangles are similar, I will use these sides, and the proportion, the ratio of all the sides should be same. That is PQ divided by AB. This is PQ. This is the corresponding side on the bigger triangle, that is AB. This should be equal to BC divided by the corresponding side on this triangle, that is QR. And the third side is AC on the bigger one and PR on the smaller one, right? So there's a problem. I need to write down. I need to fix the sides. Okay. So I'll do it this way. Smaller triangle divided by the bigger one, right? And you can do it other way around as well. That's completely your choice. So PQ divided by AB should be equal to QR divided by BC, and that should be equal to PR divided by AC, right? This is a rule. I did not talk about this rule properly. I just wrote that sides are proportionate. This is the exact same thing, right? All the ratios should be same. Ratio of this side over this side should be same as ratio of this side over this side if these two triangles are similar. Okay, so what is PQ? PQ is 4.5 divided by AB is 9. And that gives me, this is 1 times and this is 2 times. Okay, 4.5 divided by 9 will give you 1 by 2. You can use your calculators and make sure that you are getting the same thing. Let's check QR and BC. QR is 5 divided by BC, that is 10. This is again giving me 1 by 2. So far things are going well, right? And PR is 5.5 and AC is 11. So that is again 1 by 2. So what do I see? That I have 1 by 2 equals 1 by 2 equals 1 by 2. That means that these ratios are same. If this is the case, then these triangles are similar, right? So we can write it down that hence triangle ABC is similar to triangle PQR. Any confusions? Anything that you have not understood? Please tell me honestly.
No, ma'am, it's clear.
Okay, what about you, Manura and Turhan? Okay, very good. Acha, I'll clear this and I have another question. Before talking about another question, I would like to talk about one basic thing about triangles and then I would like to talk about that question. So we all know, although I have not discussed this, but I assume that this should be clear. We'll talk about this later on as well. But for now, I'll just tell you quickly and then I'll write down the example. Oh, sorry. It is congruence. Okay. So we know that, let's say if this is a triangle, A, B, and C, this angle, and this angle. Sum of angles at A plus B, right? It's a basic property. We all should know that sum of all the angles inside a triangle is 180 degrees, right? And if I have two lines of this type and they are intersecting each other, so this angle should be equal to this one, right? Because they are opposite angles, right? This means that this angle would be equal to this angle because again, they are opposite angles. Are you guys okay with this?
Yes, ma'am.
Okay. All right. Okay. So these are two things I wanted to talk about, and now I can talk about the example. And don't worry, I'll talk about opposite angles and all that later on, right? For now, we are just talking about similarity. Let's talk about another example. Again, you need to prove that the two triangles are similar or not. Okay. So it says, prove that ABE, prove that the triangle ABE is similar to ACD. Now I'll make the diagram and let's see how exactly it looks like. Yeah. This is A, B, C, D, and E. Okay. Now the thing is that you have been told that this angle and this angle, right? I made these with green. They are same. And they want you to prove that the triangle ABE, that is the smaller triangle, this one, is similar to the bigger triangle, like the big triangle in which I have the smaller one, ACD, right? Okay. Now this time around, I don't have sides and I only have one angle. So I would be using some other concepts in order to prove this. Okay, let's talk about it. Now they have told that the angle at B and the angle at C, they are same. And this angle and this angle, they are same, right? They are two angles on these triangles, right? What about this angle? Now, this is an angle that is being shared by both the triangles ABE and ACD. Okay. Yes, very good, Manu. They are corresponding angles, but for now, I did not talk about it that way because I just wanted to talk about this concept that they are similar, right? So just know that they are equal, right? Yes, you are right that they are equal because they are corresponding. Very good. Okay. Now, what about this angle? Let's say I'll use different colors. So this is angle with red and this is angle with green. Okay, so can I write this angle? Can I write the black angle this way? 180 minus red minus green equals black. Because I know that sum of angles in any triangle is 180, right? So if I minus this red angle, if I minus this green angle, I would get the black angle, right? And what about this angle? We have the similar thing for this one, that I will again do 180 minus the red angle because this red angle is the third angle of the triangle CAD or ACD, right? Whatever you call it. And then minus the green one. This is also going to give me the black triangle. This means that this angle and this angle, they are same, right? Because I will get them through the same formula. So this implies that since since three angles of both these triangles are same, they are similar. So we can write it this way. Since all the angles in triangle ABE are equal to all the angles of triangle ACD, they are similar, right? Any confusions? Anything that you did not understand in this question? Yes, Saneem, please tell me.
No, ma'am, it's clear.
Okay, and what about you, Turhan? Very good, Manur. What about you, Turhan? Please tell me. Okay, let's talk about another example now. So we have the black lines are parallel to each other. So this is the symbol which we use for parallel lines. And this is A, B, C, D, and E. And you need to prove that triangle ABC is similar to triangle DEC. Okay, now what do we know? So I told you before writing down these examples, a property that they are vertically opposite. So these two angles would be equal, right? Okay. Since these two angles are vertically opposite, they are equal. What else do we know? We know that these are two parallel lines that are being cut with a transversal. So this angle and this angle, they are also going to be same because they are alternating angles, right? So they are also same. And if we think about it similarly, so again, we have two parallel lines that are being cut by a transversal. So this angle and this angle, they are also same. Since all the angles in both these triangles are same, that is why these triangles are similar. Did you understand this, Saneem?
Yes, I do.
Okay, and what about you, Manur and Turhan? Please tell me. Okay, that is good. Acha. Now I'll talk about congruency, okay? So we'll do more examples, but I would like to talk about angles first, and then I'll talk about more examples, because this way there's no point in discussing this, right? We have to discuss angles first, and then we'll talk about it. So for now, let's talk about congruence. Okay. So in order to have two triangles congruent, we have some conditions, okay? I'll just write them down. The first one is called S, S, S. The second one is side, angle, side. The third one is A, A, S, angle, angle, side. And the fourth one is R, H, S. Okay, all right. Let's talk about it now. So this means we have three sides of this triangle and they should be same as the other triangle. For example, if I talk about two triangles in this case, now obviously I will not draw it in the same way. I'll change the orientation just so you feel, just so you think about it as if, you know, if they are similar, if they are congruent, but the concept would be same. Okay. This side is same as this side, then this one is similar to this one, and then this side is same as this side. Okay, now obviously I have made these two triangles in a different way. I did not make them in the same orientation. That is why you might think about it as if they are not same, but they are exactly same. And it could be that they don't look exactly similar because like I have just, made them without any scale or stuff like that. But the idea is that if two triangles have exactly same dimensions, if three sides of a triangle are just, and we have two triangles and all the sides are same, that means that the triangle is congruent. So that is why we have SSS, right? Side, side, and side. Three sides are same. Let's talk about the other one. So here we have side, angle, side. This one is side, angle, side. Let's talk about it now. So let's say this is a triangle. Okay, and you have been told that this side is equal to this one. These two sides are same. And this angle between two similar sides is same. So what do we see? Side, angle, side. Okay. Again, side, angle, and side. Now, what is the thing? If two sides of one triangle are of the same length, right? So let's say this side and this side, and then this side and this side, they are of the same length, then the angle between these two sides, this one and this one, if this is also same, this means that these two triangles are congruent. So this time around, you don't have to find this side and all these sides and all the angles. No, if two sides and angle between them is same, then through side angle side property, you can say that they are congruent. Okay, let's talk about the third one. AAS is angle, angle, and side. Let me just make a diagram for this one. So all right, and you have been told that this side is same as this one, this side, this angle is same as this one, and these two sides are same. Okay, so what is this? Angle, angle, side. Again, we have angle, angle, and side, right? Angle, angle, side is telling us if two angles in two different triangles, if they are same, obviously the third one would also be same because sum of angles is 180, right? But that is not the thing. If three angles are same, we are not sure if the triangle is congruent or similar, because if three angles are same, that is a proof for similarity. We need to think about the size as well for two triangles to be congruent, right? But since AAS is telling us that if two angles, this angle and this side, if these two angles are same, and if the side that is coming between these two angles is also same, then through AAS we can say that these two triangles are congruent. And then the last one is right angle hypotenuse side. So let's say this is the first triangle, and then this one is the second one. Okay. And this side and this side, they are same. This is the right angle. And this one and this one, they are also same, right? Now, what is the thing? The thing is that both these triangles are right angle triangles. So right angle, the hypotenuse side, this hypotenuse, this is the hypotenuse side, right? The side opposite to the right angle. If the length of the hypotenuse side in both triangles is same, if both the triangles are with right angle in any of the other sides, right? This side, or maybe this side and this one. If one of these is same, we can say that both these triangles are congruent triangles, right? Because if we use Pythagoras theorem, we are going to get these two sides same. Let's say this is 3 and this is 4. So we know that 3 square plus 4 square is 25. This side is 5, right? So the rule is same every time. If this side and any of the other sides in both the triangles is same, they would be congruent. So is this okay? Saneem, Turhan and Mahnur, please tell me.
Yes, ma'am.
Okay. All right. That's perfect. Now I would like to talk about congruence again. Okay. Now we'll do some examples and prove that if the two triangles are congruent or not. Okay. This is the first example. So I'll make it. This is a rectangle. A, B, C, D. So you need to prove that the triangle APD is congruent to triangle CBD. All right, now that is the idea. Now what do we know? This is a rectangle. So obviously AD would be equal to BC, right? The side AD is equal to the side BC. Okay, so first sides, like one side is same in both the triangles. Again, using the same concept, since this is a rectangle, so this side would be equal to this side. That means that AB would be equal to DC. That is good. And what about the third one? This is the third side, and obviously it is one side, it is being shared. So what do we know? Since AD equals BC, since AB equals DC, and since DB is common in both the triangles, hence by SSS, that is side, 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 ABD is congruent to CBD. So we can use the symbol for congruence. So you can just write it down directly that they are congruent to each other, right? So now we have used SSS. This is the very first type and the very first condition for two triangles to be congruent. If the two triangles follow any of these two, then they are going to be congruent. Okay, That is good. Let's talk about another one. Now, this would take some time. I'll draw it first, but it's very important example. Mhm. Okay, this we have two circles. Then this is the diameter of the first one, and this is the diameter of the second one. Okay, this is A, B, C, D, and O. And this O is the center of both the triangles, right? It is the center of the bigger triangle and the small triangle. And you need to prove that these two triangles are congruent. Now, what do we know? Yes, I did not talk about circles yet, but still, I think by now we should know that we have been doing past papers as well, that a circle has a radius and it is same every time. And what is the radius? It is the length from center to circumference. So this is the radius and this is also the radius, right? So this means that these two sides are same. Then this is the radius of the bigger triangle because this is the center and this is the circumference and these 2 points are connected, and then this is the radius of again the bigger triangle, so they're also same. So far we have two sides that are same. OD is equal to OC and AO is equal to OB or BO, whatever you want to call it, right? These two sides are same. And what else can we say? Yes, it could be that this side is equal to this one, but we do not have any information. We do not have any proof for that, right? In maths, we cannot talk about things by just saying that it looks like they would be same. No. Yes, they might be same, but we are not sure. Okay. We know that whatever angle this would be, this would also be the same because they are vertically opposite. So AOC is equal to DOB. So what is this? Side, angle, side, right? Two sides are equal and the angle between those two sides is same. That is why ACO is congruent to ODB. So ACO is congruent to ODB, right? Any confusions, anything that you have not understood, please tell me. Feel free to ask me. You know that I would not mind your questions, okay? All right. Banur is clear. And what about you, Turhan and Saneem? Please feel free to ask me.
It's clear.
Okay, then I will talk about the last question and then that's it. Okay, so I'll make 4 triangles. And yes, do not go on their appearance, right? Like, do not tell me if they are congruent or not, if they look like they are congruent. The question is that which of the triangles below are congruent? Okay. Which of the triangles are congruent? You have been told that this side, this is A, B, and C. This angle is 45.5. This one is 52.4. This side is 5. This side is 4. This side is 3.6. Then this triangle is D, E, F. This side is 3.6. This is 5. This is 4. Then it is I, G, H. This side is 5. This angle is 52.4 and this side is 45.5. This is 4. This is 3.6 and this is 52.4 and this is J, L, and K. Okay, so you have 4 triangles. You can just tell me which of the triangles below are congruent to the triangle ABC. Okay, ABC is the main triangle, this one. Keep this as your reference triangle and think about all the other triangles and tell me if they are congruent to ABC or not. I want you guys to think, take 2 minutes, and then I'll tell you the answers, okay? Yes. Any success? Like, are you guys able to do it? Okay, I have a message. It is Manur. So she is saying ACB is congruent to IGH angle side. Very well done. Excellent. And okay, very good. And what about you, Saneem and Turhan? Yes, Saneem? Saneem, are you there? Turhan, are you there? All right. So Saneem is saying JKL side angle. And Turhan is saying ABCGHI. Okay. All right. So I would like to answer you. So this is the first triangle ABC. Let's see if the second one, that is DEF, if they are similar or not. Okay. They are congruent or not, right? This side is 3.6, this side is 3.6, this side is 4, this side is 4, this side is 5, and this side is also 5. Since three sides of these two triangles are same by side, 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 they are congruent. Okay. Very well done, Turhan. Excellent. You are correct. A, B, C is congruent to D, E, F. That is good. What about the other one? Let's compare these two. Now, this time around, what do we have? Two angles that are same, 45.5, 45.5, 52.4, 52.4. Two angles are same, and the side that is coming between these two angles is also same. So what is this? This is angle side, right? This is AAS. Through AAS, we can say that they are same, right? So we have two angles, and the side that is between these two angles, they are same. That is why these two triangles are congruent. And what about the last one? For the last one, two sides 4 and 4, they are same. That is correct. 3.6, 3.6, they are same. That is good. So two sides are same, and an angle is also same. But what about this angle? This angle is not this angle. If 52 point, if we were told that this side, if this angle, and let's say if this angle, if these two angles were same, then yes, ABC and KJL, they would have been congruent, but they are not talking about these two. They are talking about this angle. So since the information is insufficient, we cannot say that these two triangles are congruent or not. It could be that this angle and 45.5, like they are same, but we are not sure. This information is insufficient. So that is why these two triangles are not congruent, right? Now, Saneem, you were saying that they are congruent because of side angle. No, it is side angle side. Okay, that means that the angle should be between those two sides, right? It is the angle J and it is the angle C. We are not sure if they are same or not. We have been told that B and K are same, but that is not good enough for us, right? So we do not have sufficient information for this one. That is why we cannot say if these two triangles are congruent or not, right? So any confusions, anything that you have not understood? All right. Okay, Saneem. All right, then that is it for today. I'll stop the recording, and if you have any questions, you can just ask me.